a session on resistance. Okay, we'll cover the topic. Under this topic we will cover what is resistance and what are the factors affecting the resistance, and we'll see some numericals on that. Okay, so our topic for today is resistance, right? So what is your understanding for resistance? Let us discuss that. Okay, a resistance is a physical quantity, is a physical term, right, which is used when certain material, it can be a conductor, it can be a insulator, and it can be a resistance which we are discussing. Okay, so the resistance of a material is the restriction or the hindrance which is hindrance or the objection which is applied by that material for the flow of electricity or heat through it, right? So let us say if this is a material, okay, and it all depends upon the various factors, right? Suppose it all depends upon the nature of the arrangement of the electrons and protons, that is the molecules, or the nature of the arrangement of the atoms inside the material. Okay, it all depends that how much of the current through that material is passing through it. That means if that current is just applied to one of the terminal, then through another terminal we will get that current. But before that there is some hindrance, there is some objection applied by this material, and that hindrance or objection is called resistance, right? So basically resistance, can we can see the resistance can be defined as, I just understand, and I'm assuming that under the Ohm's law we have already discussed that V equal to IR, right? That means it is inversely proportional to the current and directly proportional to the voltage, right? So this is one of the relation which we are understanding and knowing it. I'm considering it. Yeah. Hi Twinkle, hello, good morning. So here we will discuss that the material, every material has certain quality, and the atoms arranged into that material, it all depends that how much of the current will pass through it. Okay, so the current is the flow of electrons. Okay, current is the flow of electrons. So if any electron, I'm writing just minus, so if electron is trying, suppose current is flowing, that means electron is moving, right? So if that electron is moving, there will be protons, right? Protons, that means positively charged ions across the material, every material, right? So they will create some hindrance into this flow. So if these protons will be creating hindrance to this electron, if this is, I'm considering and zooming one of the electron, okay, so that just for understanding, if this is electron and these are the number of positively ions, that is all are positive or protons, right? So here you can see the electron is not directly allowed to flow from A end to B end if this is A and this is B. Okay, because these are the enemies to this electron, right? I cannot say enemy, but definitely they will produce some hindrance. They will not directly allowing this electron to reach from A to B, and this electron will not be easily reaching to this. So that's why this electron will encounter and struggle with one of the proton. Again after this it may reach to this point, after one it may reach to second point, then again it need to struggle with the another proton, and after that it need to go to this one, this electron need to struggle with the third proton, and likewise after doing that lot many of struggles with all those protons, I should write with all protons with black, this electron is emitting here, this electron is emitting here after lot of objections. Who created the objection? The lot of objections were created by these positive ions, which are called protons, right? So this structure or this concept is creating the fundamental of resistance, and this property is of any material or any item is called resistance, and every material has certain resistivity. Okay, so we will understand resistivity also. So this is the resistivity. What is resistivity? In a simple language, I want to explain you. Resistivity of any item, resistivity of any item is the quality of that item which will exhibit that how much current will be flowing through it, right? Resistivity of any item or material depend upon that how much of current will be passing through it, and this is the quality of the material, and that is resistivity represented by rho, right? So this resistivity is simply saying you that suppose the value of resistivity can be x of maybe gold, okay, the value of resistivity may be y for silver, right? These are the metals I am considering, and the resistivity of maybe wood will be z, right? Like sulfur and any. So this list can be anyone. So basically the list of the resistivities in your numericals, it will be provided to you. Okay, so need not to remember all this. Okay, that you need to understand. And this is the concept of resistivity which created this resistance, right? Now let me explain how this resistance is related. Through the Ohm's law, the voltage is directly proportional to the product of current and resistance, right? That we already understood. But you can see through the NCRT, there is an example that when you current a electric circuit, and here there is an ammeter. Ammeter is a device. What is a device? What ammeter does? Tell me. Ammeter is a device which measures the current which is flowing through it, right? So here just put a rheostat. Rheostat is a device which can provide variable resistance through the circuit. So okay, so it is represented like this, and here it's an arrow, okay, and you can see through this arrow, if we are sliding it, if this is at this point, the depending upon this length, the resistance will be something, and if you slide this arrow maybe at this point, you can see the length of the resistance is shortened, and definitely the resistance will be varying. Okay, so here in this experiment of NCRT, what we have seen that, and here we have used the nichrome wire, okay, this is just an example. So whenever we are varying the resistance or varying the length of this electrical wire, okay, don't think that this is corrugated, this is just a representation of resistance. Okay, you can simply understand that here we have connected a wire of 1 meter length. So when a wire of 1 meter length is connected through the circuit, let us say the ammeter read 20 ampere of current through it, through the circuit, okay, through the circuit. And when the length of this wire is shortened, maybe let's say 50 centimeter, that is half of that in the second case. Yeah, nichrome wire hits definitely SAF, you are right. And H equal to I square RT. So that is a relation that will be different. So we are just understanding the concept of resistance over here, right, SAF? So let me try to conclude this. After that, I will come into the numericals. Okay. Thank you for your patience. So here you can see, if you decrease the length of this nichrome wire, if this nichrome wire or this wire, right, if this wire length is reduced with 50 centimeter, then suddenly what we observe, that the current is increased from 20 ampere to 40 ampere, right? So this shows that, and again, when we took the this shows that the resistance is proportional to the L, right? This shows that resistance is directly proportional to the length of any conductor or insulator, whatever you are considering, right? Now, after that, another experiment was performed, and into the another experiment, what happened, again same ammeter was fixed into that circuit, okay, and here the electrical wire is placed, but here let's say the cross section of the wire is, I'm saying, 1 centimeter, right? This is the cross section. I hope you understand, this is the cross section. That means the upper section, if in the cylinder you can see, right? So this is just cylindrical shape. So if the cross section, let's say this is the area of the cross section, here is pi r square, right? So for the cross section of the wire, if it's 1 centimeter, and let's say the current flowing at that moment through the ammeter is again 10 ampere, right? And after that, when we consider another circuit where ammeter was placed, and in this point we have changed this wire with another wire which is having a bigger cross section, okay. I am zooming it, that's why you can see it's at a cylinder, but this is not like this is just a wire. This is just a wire, and this was just a wire. So when we increase this cross section from 1 centimeter, so this is R, area will be pi r square. So okay, so from 1 centimeter to let's say 2 centimeter, right? When we increase the cross section, just not use the value centimeter, because this area will be centimeter square. So from 1 to 2, if the values is higher, if this is increased, then we have seen that the current through this ammeter have been, since the resist, we have observed that R was proportional to L into the previous experiment. So through this experiment, we have observed that R is inversely proportional to A, area of cross section. That means that whenever the area of the cross section is increased, then the current through this ammeter is what? Tell me. The resistance is directly proportional, not inversely proportional to the area of cross section. That's why the current through this is doubled, halved, 1 by 2. Why 1 by 2? Because suppose the resistance earlier is R equal to rho L by A1, okay. So initially for A equal to 1 centimeter, the resistance was rho L by 1, that is rho L, right? We have taken the same length, right? And again into the second case, where the resistance is considered as area of cross section is considered as 2 times, then at this point of time the resistivity RL by A1 gives, in place of A1 it's A2, right? Here it's A2, right? And in place of A2 we have seen rho L by 2, right? So we have observed that the resistance through this circuit is halved. Resistance is halved, that means the current through this ammeter is increased, right? Is increased. So if the current is increased through this ammeter, that means the resistance is half. So we observe that whenever we are increasing the cross section of this metal wire which is connected through the circuit, then we observe that the resistance is gradually decreasing. Okay, so we get the observation, we have the observation that R is inversely proportional to the area of cross section, right? So R is, what's your maths? Yes, yes, maths is also there, but yes, yes, I got you. We will discuss it later on, the maths. We will just try to conclude this topic first, okay? So these are the two things which we derive from the experiment, that is R is proportional to L and R is proportional to, inversely proportional to A. So this gives you a relation that resistance of any item is uh, proportional to length. Resistance of any item is inversely proportional to A, which can be written as R is proportional to L by A, and when we just remove the proportionality, you get R equal to rho L by A, right? So R equal to rho L by A is a relation which is derived where we can see whenever you are gradually increasing the current, increasing the length of the conductor, then we see that resistance is gradually increasing, right? Whenever, suppose you have certain lengths, and when you observe the resistance of that particular and you plot that, then what we see, then when length is 1 meter, resistance is something, let's say 2 ohm, right? When we increase the length, let's say 2, then the resistance will be, can be 4 ohm. When we increase the length to 3, then resistance can be 6 ohm. So in this way, we observe that R is directly proportional to L, right? Similarly, when we plot with A, then you can say that if this is A, area of cross section of any item or material, and if you plot it with resistance, and what is the values of the resistance which you get when you have the area of cross section, let's say 1, then the resistance can be 10 ohm, right? When the area of the cross section is, let's say, doubled, so it's 2, then the resistance will be halved, so it will be 5 ohm. When the area of the cross section is, let's say, 5 ohm, 5 centimeter square or meter square, then accordingly the resistance will be 2 ohm. So this shows that resistance is inversely proportional to the area, and resistance, and the this table shows that resistance is directly proportional to the length. So that's why we have the formula R equal to rho L by A, right? Now let us solve some questions on it, okay, on R equal to rho L by A. So before taking that question, I want to, yes, we can take some examples. Let me take it from a book. So the questions can come to you into this format. What is the electrical resistivity? What is the electrical resistivity? That means resistivity of a material is asked over here. Okay, into this question, the resistivity of a material is asked. If in a series electrical circuit comprising of resistor having a metallic wire, the ammeter reads 5 ampere. So into this question, the value of I is given to you as 5 ampere, right? We need to find the resistivity, right? The reading of the ampere decreases to half when the length of the wire is doubled, right? Why? When the length of the wire is doubled, suppose here into the initial condition, the length of wire is L, right? Or L1 is equal to L. And when the length of the wire is doubled, that is the second length will be equal to 2L, right? In that case, the reading of the ammeter decreases to half. That means the I becomes 5 by 2 ampere, that means 2.5 ampere. This is given to you into the question. Now what is the reason behind and what is the resistivity that we need to calculate? So the reason behind we have already discussed and shown you into the table earlier, that since R is equal to rho L by A, right? And here you can see R is proportional to L and R is inversely proportional to the area of the cross section. So that's why when the length was L, right, resistance was something, let's say whatever it be, okay, and when the length of the wire is doubled, then resistance will be doubled, and when the resistance will be doubled, we follow V equal to IR, the Ohm's law. This is the standard Ohm's law. So here you can see you are saying that if the resistance is doubled, that means if this is doubled, right, if this is doubled, then what will be the value of I? The product should be constant. The product of I and R should always be constant. So if this is doubled, definitely I need to become half. I need to become half. This should be halved, right? Then only the product of I and R will become constant, and this will give you the product of I and R should always be constant, right? Always constant. That means if this is multiplied by 2, then I need to be divided by 2, right? Then only this will be giving you constant V, constant constant value of voltage, right? So this is the solution. This was asked that when the length was increased, why the current was halved? When the length was increased, current was halved, because every circuit follows this V equal to IR, where this conductor, where R is doubled, then definitely the I should be halved, otherwise the product of I and R would not be a constant, right? So that's why the value of this is calculated, right? Now we have to find the resistivity of the what is the electrical resistivity. So this is not resistivity that need to be calculated. So the resistivity definition, it has been asked into this question. So the resistivity is basically nothing but it is the resistivity of any material is defined as the resistance of a conductor made of that material of unit length and unit area, right? So this is the resistivity what we discussed. It all depends upon the quality of the material. Every material had certain resistivity, and the opposite of resistivity is conductivity, right? So in this way we have solved this. Now let us take another question, question 2 on this, before quickly winding up. If the length of a metal wire is given to you as 2 meter, right, and the area of the cross section is given to you as, let's say, 1.55 into 10 power minus 6 meter square, right? Now if the resistivity of the material is given to you, this is given, it's maybe 2.8 into 10 power minus 10 ohm meter, right? Then when the question is asked to you, then what is to find the resistance, what is the value of R? To solve such questions, you can simply use the formula R equal to rho L by A, because these are the factors on which the resistance of a material depends. That is the resistivity of that particular material from which that wire is made, maybe tungsten, maybe gold or silver, aluminum, whatever, copper. So the value of that resistivity and the length what we have considered. So into this numerical, here the length is given to you as 2 meter, the area of cross section is given to you. So you can just simply put up the value of rho over here, multiply it with length of 2 meter, multiply it with and divide it with area of cross section 1.55. So this much of ohm is your answer, right? Now quickly taking the third question now. Okay, the question number 3. So this is a basic concept clearing, understanding the concept of resistance. We have used this session. Okay, so if there is a question that if a wire of resistance 10 ohm, so it's given that a wire is there and the value of R is given to you as 10 ohm, right? Now here this wire is stretched to double its length. So let us assume the length of this wire which is given to you is L. Now the new length will become how much? Double its length, because this is stretched to 2L, right? Now the question is that what will be its new resistance in this condition? What will be the new resistance, right? So here you can see we again use the same formula, R equal to rho L by A. This shows that when when the length is L, the resistance is 10 ohm, right? And here you can see R is always proportional to L, right? That means when the length was L, this one, the resistance was 10 ohm. And when the length is 2L, then the resistance will be rho into 2L by A, right? Rho into 2L by A. So this will give you rho into L by A multiplied with this 2, and this, let's say this new resistance is R dot. So the value of R dot is rho L by A into 2. So this R rho L by A is nothing but what? This is R. This is R. R multiplied by 2 is the value of R dot. Is the value of R dot which is calculated. That means when the question is asked to you that a wire of resistance 10 ohm is stretched to double its length. So in that case, let us assume the initial length is L, then the double length will be 2L, because 2L represents double length, right? In that case, using this formula, we can say that if the earlier resistance was 10 ohm, the new resistance will be 10 into 2, because R into 2 and R is 10 ohm. So this will give you 10 into 2, which will give you 20 ohm. 20 ohm is the value of new resistance R dot, right? So in this way we can solve such questions, and this will help you. Okay, we can solve, you can take multiple questions on this. Okay, and for any query you can put up into the comment box. I will help you out if you are stuck at certain point, but I am sure if you are having a proper concept of this, then you are not having any doubt and any problem in solving such questions. Okay, but you can solve different types of questions from this topic, so that you can have a better grasp over the topic and over this subject, so that you can have a you can further crack some examination which is your dream. Okay, thank you so much for watching, students. Take care. Bye bye.